and he is a very distinguished magician. Professor Derek Bones is a professor of molecular biology and zoology, and he's from University of Wisconsin. Please, Professor Bones. Thank you.
So these speeches are meant to be hopefully something where you share the Yes. Actually, about a year ago, I got this strange email. They said, "Is this real?" And I said, "Oh, well, gee." So I called up some of my professor friends in Istanbul and said, "Is this guy okay?" And yeah, he gives good meetings and very, very good people. So thus reassured, I'm very grateful that you invited me here, and enjoying the talks and looking forward to the other ones. Now, what I got to basically was invited to give a talk on a topic of my own choosing, and what I would like to do, perhaps slightly different from the frame of the conference, is to try to describe my own primitive understanding of the nature of our subjective I, the thing that's wanting to know how it works, that's in this meeting. The first slide, go back one slide, or here I can go back one slide. There we go. This first slide is to just give you who I am. And it also points to some of my websites. You don't need to take any notes on the talk unless you want to, because I put the talk and its illustrations on that URL, the second URL there, with the figures and so on. And the pieces that I've just played are actually I put on YouTube. In this shown there. Now, I want to mention that my interest over the last 20 years or so in evolution of mind and consciousness derives from an interdisciplinary course that I developed at the University of Wisconsin called The Biology of Mind, and then a book of that title that I wrote, and then the blog indicated in this third URL here that I continue to write. I am not an experimental cognitive neuroscientist or effective neuroscientist. My laboratory work over the last 30 years has dealt with the molecular basis of visual transduction, and hence my association with the laboratory of molecular biology. Now, this talk is to try to set some context on or frame the who, or the I in each of us that is studying minds at this meeting. Our experienced selves are supported by evolved social brains whose neuronal circuitry allows mirroring or mimicry between the selves that each of us experience, so that we can feel, for example, an emotional resonance that goes with listening to and sharing a piano performance of the sort I was just offering to you. And that's why I chose these short pieces with a feeling in them to try to make this point. Some, quite explicitly labeled as romantic or erotic. One is melancholy. At any rate, some simple experiments that I'm going to mention compel us to conclude that the self, or I, that can have rich feelings on hearing music like this, is in fact a virtual machine of sorts whose operation is quite alien to our experienced self. Metzinger has used the term ego tunnels to refer to these machines. And I want to start by talking in this first section here about the lack of a correspondence between our subjective experience and what we as neuroscientists know to actually be going on inside our heads. There are a number of simple experiments or demonstrations, some are probably familiar to some of you, that give us a glimpse of the Martian inside that's really running the show that our self-illusion usually takes credit for. Now actually, perhaps the most simple demonstration, which given our limited time here, I don't think I'll actually do, but would be to ask you all, just in the audience here, to close your eyes for a moment, to become quiet and just breathe. And I would instruct you to have no thoughts for 3 minutes. Just sit quietly, no thoughts, images, or feelings, just nothing. And then I would ask how many of you were able to follow this instruction. And the answer would be 0. Unless some of you were very experienced meditators. And so the question is, if you're running your own show, if the thing that's the I is running your own show, what's the problem? Thoughts just keep popping up from somewhere. Well, I guess that's not you then. It's some kind of it in there, or Martian, a brain that is generating this stuff in spite of your conscious best intentions. And that's what it's designed to do, generate stuff, regardless of whether you, in quotes, want it or not. So it's this thing, or this it, that I want to focus on in today. I want to deal first, in this first part, with how our subjective self does not monitor what's really going on in action, perception, or even our assignment of location in space. And after describing how far off base our subjective experience is and knowing what's going on, I want in the second part of the talk to discuss how we might make a model, attempt an explanation of our subjective self as a virtual machine of consciousness comprised of what are essentially virtual organs, such as emotions that form and dissipate according to an occasion, and how it's based on mirroring with other people or virtual machines, and finally how our use of increasingly sophisticated levels of mirroring generate through evolution increasingly complex varieties of this thing we call consciousness, or what we call an I. And alongside this evolution of the self, we can look at the increasingly complicated emotions of human communication through facial and body gestures as evolved emotional organs of consciousness. And having done this sort of bottom-up modeling in the first two sections of the talk, I want to take part three to take music as a specific example of the way in which these impersonal mechanical processes can ultimately yield the richness of our subjective emotional lives. And in this section then I want to discuss just briefly arguments for our music faculty as an evolutionary adaptation that's enhanced the survivability of groups of humans. So this is basically specifically considering music as an evolved emotional organ of consciousness. And then finally, a brief summary at the end of our I illusion. So, to start up here at the top with action. In the well-known experiment by Benjamin Lebet, a subject is instructed, flex your finger to push the button when you feel like it. And tell us where the hand on the rapidly moving clock is when you decide to do that. Now, the time at which an EEG signal indicating brain activation for movement is set at the 0 time, okay? And the report of awareness of intention to push the button is at about 350 milliseconds. About 0.35 seconds later. And the actual EKG, the voltage in the finger muscle doing the push, happens about 200 milliseconds after that. So what this very simple experiment says is that we are late for consciousness. The brain has already started an action before we think we intended it earlier than our consciousness of it. We usually assume that our experience of consciously willing an action and the causation of that action by our conscious minds are the same thing, but they are entirely distinct. And the tendency to confuse them is the source of the illusion of conscious will. Actually, the situation's even more dramatic than suggested by these early Lebet experiments and more recent fMRI studies. Activity in the brain predictive of movement can be present already in frontopolar cortex 7 seconds before a subject's subjective motor decision. This next figure is Daniel Wegner's way of summarizing the situation. Something inside is generating the first preparations for the actual movement and also generating our thinking that we are starting the movement. But the actual causal paths, but our experience is this apparent causal path. And you ask, well, how does this make sense? What's the point of this delay? What's the point of our even being conscious if everything is ready to go before we know about it? Well, we do become aware of before it happens, and we can veto it. Most of the time, it's okay to be efficient. We really ought to get going with it fast, and it's okay to get going with it fast and wait for consciousness to develop. But in case the movement ought to be suppressed, like socking someone, we can inhibit it at the last minute. By the time we're aware of willing a movement, it's well underway, but we do get to edit or cancel it. So it may be that our conscious selves don't so much have free will as the free won't. So this is 2 points I've made about acting. It's faster than our consciousness of it, and maybe it's better to consider it as free won't than free will. The point is that the consequences of any action are programmed back into the next automatic startup of the next action as an anticipation. This information's information's presented back to the underground processing that's preparing for the next instant of action that we are going to retroactively intend. Our brain is working in an extended present that contains the moment's antecedent to our awareness of thoughts and actions, and also persists as their consequences are integrated back into the ongoing cycle. So a delay in the time it takes us to be conscious of things that are already going on in our brain can be illustrated another simple way with the second item on my list there, perception. And in that experiment, the instruction is to press the button in response to a light coming on. The button push occurs about 200 milliseconds after the light comes on. Now, if the instruction is to slow down your response by the tiniest amount possible, then approximately 700 milliseconds passes before the button push. There's a quantum jump of half a second waiting for consciousness to develop if a conscious rather than an unconscious response is requested. So we get to add to our developing summary the fact that sensing can be faster than consciousness. Again, we can ask, what's the point of this half-second delay of consciousness? Well, there is one. Our unconscious or our undermind can shape what we think we're perceiving out there in the real world. Now, I just flashed a slide back past. Was that an ace of spades or an ace of hearts? How many of you thought it was an ace of spades? Was anybody? Yeah, there you go. And how many thought it was an ace of hearts? Several hands. Good. Well, okay. Here's what it was. It was an impossible card. A red ace of spades. Okay? So, you see, we actually know of the deck of cards, and we know what we expect, and if the stimulus is fast or ambiguous enough, we'll decide we saw what is in our library of images, and assume that the correct stored image is the correct one. So that a brief summary then is that both acting and sensing are faster than our awareness of them, permitting editing functions to intervene and shape both our final actions, like a free will editor, and perceptions, in the sense of seeing sometimes what we think ought to be there rather than what is really there. Now, a spectacular recent demonstration of our brain's transforming and editing power comes from work of Blanca and his collaborators, showing that we can move our perceived ownership of body parts or our whole body out in space, like to avatars, making that movie Avatar seem very timely. We can disrupt the spatial unity between ourselves and bodies. We can change the perceived location of our physical selves, and here's that experiment. A participant in the dark blue trousers there, that's the real person, sees through a head-mounted device his own virtual body, the light blue figure, in 3D, standing 2 meters in front of him and being stroked synchronously at the participant's back. So the dark colors are the actual location of the physical body, and the light colors are the virtual body that's seen on the head-mounted device 2 meters forward. Okay, so the subject is feeling a stroking on his back, but he's seeing a similar stroking on his virtual image projected 2 meters forward. This is a multi-sensory conflict. The vision of the virtual image being stroked is telling him something different from the felt touching on his back. And in such a situation, vision typically dominates over proprioception and touch. And in this case, participants start to feel that the virtual body seen in front of them now is their own body. And they mislocalize themselves to the virtual body to a position outside their bodily borders. Well, this indicates an amazing plasticity in assigning where ourselves are, even in space, based on sort of multisensory and cognitive processing of bodily information. Let me see, I need this. So these simple experiments that I've gone through just here in section 1 show us that our subjective eye is late to acting and sensing, essentially being an after-the-fact report, and can place our subjective bodies outside our actual ones. I could go on with this list, noting experiments that show how flexible our assignment of agency is, how easy it is for us to think we're responsible for something when we are not, and vice versa, or experiments showing that our value assigning emotional brain works largely outside of our awareness in a parallel track. So showing how much of the real machinery of our mind, our subjective eye, is unable to experience or not experiencing correctly brings us back to the title of the talk, really. Who wants to know the nature of our subjective eye? What's the best description we can manage of what's really in there? So I want to move on then to this second part of the talk, which is modeling our subjective selves. A number of philosophers of mind and cognitive neuroscientists are outlining what seems to me an emerging consensus view that I think is subjectively and objectively satisfying, describing the subjective eye as a virtual machine. I think Thomas Metzinger has done one of the most clear and accessible summaries, and I'm following some of his points. In describing this virtual machine of consciousness. Now, what he calls, Metzinger calls the ego tunnel or the phenomenal self model, is a complex property of the global neural correlates of consciousness. Now, today my topic is not neural correlates of consciousness. That's a whole other talk, and amazing progress is being made on that. But anyway, we're describing a phenomenal self model, property of the global neural correlate of consciousness that makes mindness or I possible. It is a vastly reduced model of what is really out there in terms of the richness of the physical world, most of which we do not sense. It is a transparent mental image that allows the conscious experience of being a self to emerge. Transparency is our not seeing the firings of neurons in our brain, only what they represent for us. The model, self-model, at a given moment is transparent because the brain has no chance of discovering that it is a model. It's a higher order representation integrating its information in longer time windows than the lower order information processing in smaller time windows. Our visual perception time window is much larger than the time windows of primary visual processing, and so those more rapid underlying processes are completely invisible to it. It's the same thing as not being able to see the individual frames in a movie reel because our visual integration time is faster than the flipping by of individual frames. This is a metabolically efficient, quick, and dirty way of knowing only what our evolution has deemed it necessary for us to know. Our ancestors did not need to know that a bear representation was currently active in their brains, or that they were currently attending to an internal state representing a slowly approaching wolf or something. They just needed to know bear over there, or wolf approaching from the left, the bottom line. In this view, consciousness is really just the space of attentional agency. That set of information currently active in our brains to which we can deliberately direct our high-level attention. Low-level attention is automatic and can be triggered by entirely unconscious events. A further assertion is that consciousness is epistemologically irreducible. There's one reality, one kind of fact, but in this case, two kinds of knowledge: first-person knowledge and third-person knowledge that simply are not appropriately conflated, can never be conflated. Now, there is a long list of ideas on why consciousness has evolved, what it is good for, doing goal hierarchies, long-term plans, enhancing social coordination, etc. I think Metzinger's description of consciousness is a new kind of virtual organ. Unlike the permanent hardware of the liver, kidney, or a heart that's always present, it's a transient virtual organ that forms for a certain time when it's needed. Things like desire, courage, anger, or an immune response. They're a new computational strategy that makes classes of facts globally available and allows attending and flexible reacting within context. This kind of focused reality generation allowed animals to represent explicitly the fact that something is actually the case. The world is present. Conscious color gives information about nutritional value, red berries and green leaves. Or empathy gives information about the emotional state of a conspecific. Old things in the evolution of consciousness are ultra-fast and reliable, like qualities of sensory experience, and they're transparent. They're evolved hardware, as are our autonomic and neuroendocrine emotional chemistries. They're supported by evolved hardware. The evolved hardware supports this new class of transient virtual organs. Abstract conscious thought is not transparent or fast. It's very slow and unreliable. We experience it as made. So it's likely that only our species has developed sort of these advanced additional capabilities to run offline simulations in the mind, experiencing some things as real and other elements of our self-models or ego tunnels as mere thoughts about the world. We can represent that we are representational systems. And underlying all of this are our brain's mirroring system. As monkeys view other monkeys, or humans view other humans, making purposeful actions towards a goal. Nerve activity is observed in the nerve cells, which are dubbed motor neurons. It would become active if they were carrying out the task themselves. Observed emotions are mirrored, and so here we are mirroring. Observed emotions are also mirrored by activity in emotion areas of the rat brain, monkey brains, our brains, suggesting that they're a basic substrate for building empathy between conspecifics. The common view is that the mirror system is a complex form of representational content that functions as a building block for social cognition and for a more complex, consciously experienced representation of the first-person perspective as well. Now, we'd have to say that our sense of I has several nested components. First is a phenomenal animal substrate I looking out on the world with a sense of just being that doesn't include explicit self-referential awareness to being in that state. Animals do not see into a moment, rather they look out from it. Subjectively, an animal brain would always be facing forward, focused not on where the latest shift in viewpoint has come from, but where it's heading. Rather than feeling like an observer or a passenger, an animal would have a feeling of simply being the vehicle, of doing the journey. But then is suggested by mirror self-recognition experiments in monkeys, dolphins, some birds, a more advanced sense of mindness, that is, having a self. Yet still not necessarily reflecting on it, its history or its future. Our human feeling of being there during a moment, observing, supervising, and taking decisions may be a veneer or habit grafted onto this basic animal kind of consciousness. And then finally follows our visual, gestural, mimetic, I think most likely pre-linguistic I that can reflect on itself as well as a past and a future. The eye, and then there's excuse me, and then there's finally the eye that recruits language past the visual mimetic stage, both inner and outer dialogue, giving us the more grandiose eyes that underlie myth and artistic things, like the grandiosity of this Dionysian Menad that I've grabbed a slide of. Now, can we build on the basis of, modeling like this towards a description of how, over evolutionary time, the impersonal mechanics by which our brains generate these increasingly complex virtual models of our subjective self might have led to the experienced richness of our emotional and artistic expression? Now, to do this, I think we can use the model of describing aspects